Hello everyone, in this video I'll talk about which all fragments lifecycle methods are being called during different cases of fragment transaction. That is, on add, replace and remove of fragment. In my previous video, I already spoke about what lifecycle methods are called when the fragment is added to an activity and when the fragment was removed from an activity on press of back button. You can also pop a fragment from the back stack by doing this, which will remove current fragment and replace it with the last one from the stack. For this to work, you need to do add to back stack on the last fragment transaction. I'm closing this fragment on click of pass the data button, which passes a counter value to the activity using this callback, as I discussed in the previous video. Here, I click on pass the data button and this value is passed over the screen as we close the fragment A to get to the screen. And these are the callbacks called. You can also remove a fragment by using this. We obtain fragment A by this method, find fragment by tag. For this to work, that is, find fragment by tag should return a fragment, not a null. You need to add a tag in the third argument of add or replace methods. Otherwise, this method would return null, as I said, and lead to crash resulting in null pointer exception. If we remove this tag, now we run these changes. This resulted in a crash when I closed the fragment, because when we obtained a fragment by this method, it returned null. Now let's include the fragment tag and run again. And these are the callbacks called. Notice that onDestroy and onDetach method are not called, whereas these were called when we used pop back stack to remove the fragment. The reason is we've added the fragment to the backstack in the main activity by including add to backstack in your fragment transaction. This would retain the fragment in the backstack record attached to its activity. Only its view is destroyed. When we remove add to backstack, and run it again. Now you see, we would receive the same callbacks as we did on pop backstack method. Pop backstack would remove the fragment from the backstack record, hence disconnecting from the activity invoking onDestroy and onDetach method. You can also remove a fragment by obtaining a fragment by its ID. I prefer using tags because they are unique to a fragment. And all the fragments added or replaced have only one ID associated, that is of the frame layout. So we can't use that to obtain a particular fragment. Now let's understand fragments lifecycle with respect to the different fragment transactions mentioned here. For this, I've added another fragment B similar to fragment A, only with a layout change. I'd explain it to you with respect to the demo I show you, starting with case 1, when fragment B is added to fragment A. I launch the fragment B from fragment A. Notice that there are no lifecycle methods called for fragment A. You only see it for the fragment B. But why is this? Isn't it on-stop method as we called on a fragment A, as fragment A is not visible? And we see none of the callbacks being invoked when new fragment, that is fragment B, is added in the same activity. This is because fragment A will only be affected if it's removed or replaced, like in case 2, when fragment B replaces fragment A, and case 3, when fragment B replaces fragment A, keeping it in the backstack. Simply adding another fragment would just display fragment B over fragment A, and no lifecycle callback should be called. Now, when you return from fragment B to fragment A, you will see no callbacks invoked when you return from fragment B from fragment A, and we expected onStart to be called. Again, since fragment B was added on top of A, fragment A is not affected by the removal of B. Coming to case 2, when fragment B replaces fragment A, this would be the remove operation combined with the add operation, which would give your replace operation. Using replace instead of add, which would replace fragment A with the fragment B. Let me run this on the emulator. These are the lifecycle callbacks called for fragment A and fragment B. For fragment A, it would be on pause, on stop, on destroy view, on destroy, and on detach. For fragment B, it would be on attach, on create view, on view created, on activity created, on start, and on resume. Everything works as per expectation. Fragment A wouldn't be visible, and we see these callbacks. And fragment B is newly created, and any newly created fragment's lifecycle will be as follows. Coming to case 3, when fragment B replaces fragment A, keeping it in a backstack. Now adding add to backstack to the fragment transaction, the tag, run this on the emulator. These are the lifecycle callbacks called for both fragment A and fragment B. Notice that on destroy and on detach method of fragment A is not called. Why it's so? As we saw earlier in case 2, we replace a fragment with a new fragment, and its lifecycle callbacks included on destroy and on detach. As this would because, unlike a simple replace, when you add your replace transaction to the backstack, you're actually keeping the first fragment attached to its activity. Only its view is destroyed. And also we have seen this earlier when we removed a fragment A from the activity without using add to backstack. On destroy and on detach is called when you disconnect the fragment from the activity by calling add to backstack method. The replace transaction is saved to the backstack record, which is kept for each activity. So the user can reverse the transaction and bring back the previous fragment by pressing the back button. Hence it stays connected to the activity. If you have removed or replaced a fragment and haven't added it to the backstack, you won't be able to find it in the record. Once you pop the fragment B from the backstack on press of back button, these are the lifecycle callbacks called for both fragment A and fragment B. Fragment B is removed and fragment A will just recreate its view starting from on create view. Here is the bank would represent an activity, bank teller represent fragment manager, and customers would represent fragments. Just like the bank clerk who keeps records, accounts of the account holders. Fragment manager manages the fragments in an activity and their backstack record. It deals with the fragment transactions such as add, remove, replace a fragment. These fragment transactions are similar to creating or closing an account for the account holder. If you create an account, customers would be the part of the bank. On closing the account, they'll no longer be associated with the bank, which is similar to adding and removing the fragment in an activity. By this, I conclude the session for Fragment's lifecycle callbacks during Fragment transaction, which is part 2 video for Fragment and its lifecycle. Hope you enjoyed this video.